afternoon, and today we have Dr. Claudionor Coelho to join us. I hope I spell it right. Yeah, and on a topic that is very interesting. It is about like AI agents, copilots, and autopilots. Yeah, and a little bit of background of Dr. Coelho. So he's now the Chief AI Officer at ZScaler. Before that, he also served as a Chief AI Officer and SVP of Engineering at Advantest, where he was developing some zero trust private cloud solutions. And also before that, he was the VP and Fellow of AI, and also the head of AI Labs at Palo Alto Networks. He holds a PhD in electrical engineering and computer science from Stanford University. And yeah, Dr. Coelho, please take it away. And we're really looking forward to this.
So can you guys hear me okay?
Yes.
So by the way, for PhD students, 30 years ago, this was me, okay? So there is like a light at the end of the tunnel for you guys. So anyway, let's see. Let me just move this out. This is me, like I'm right now Chief AI Officer at ZScaler. I'm also an invited professor for deep learning, machine learning, and NLP at Santa Clara University. Before that, I was talking about a private cloud for protection of semiconductor manufacturing. And I had this presentation on the LinkedIn. If you just go to LinkedIn and you connect to me or search for me, then you're going to find the slides there. And it's very interesting because I was talking about cyber attacks are inevitable. Protection is not enough anymore, and we have to do containment, especially in semiconductor manufacturing. We can do like the containment strategy very well. As it was mentioned, I was at VP and fellow for and chief of the AI labs at Palo Alto Networks. I was working before at Google, and I created quantization library called QKeras that was used by CERN, and that was the cover page of Nature Machine Intelligence, the work that we did there. And I have held several positions in EDA, electronic design automation, and I guess that's it. And by the way, if you guys want to ask any question, basically, please ask the question. I'm not seeing who is raising the hand, so you probably have to say something.
Yeah, we will monitor the channel, and if there are any questions, we'll let you know, okay?
Okay, thank you. So just a warning here, this talk is not about LLMs. And the reason for that is that LLMs alone are very boring, expensive toys. You need to connect LLMs to real data to be interesting. And this talk is going to be on how to make those LLM-based systems with connection to data work, okay? And it's very interesting because I gave this talk before without showing this book, but I realized that most of the people have never seen this book before. Around 50. Huh? Yes?
Yeah, there are some random noises. Please mute yourself, folks. Yeah.
Okay. So some people basically are saying, like, we don't understand this title, and you have to understand that this book here on the right, actually, let me just play the pointer. So this book here was written around 50 years ago about the traps of software engineering. Brooks was probably one of the first people who said that there were no magic bullets in software engineering. And I keep joking, saying that when LLMs came, people threw software engineering into the trash. And what I'm trying to do is just to make software engineering a practice when you have LLM-based systems. And one of the examples that I just basically say is this. If you go to the quotes of Brooks, just replace man and woman by LLM, and then this book is like new book, okay? For example, one of the quotes from Brooks is like, adding manpower to a late software project makes it later, and you just replace manpower by LLM, and then it becomes so 2024. Adding LLM power to a late software project just makes it later. And it's very funny when I say that, because in 2023, a lot of people promise LLMs, and they realize that LLMs are not the answer, because LLMs needs to be connected to the system. If they're not connected to backend systems and to tools and things like that, they don't do anything quite useful. They're good for playing, okay, by the way, and spending our time basically playing with them. And then basically, once you have that, then you start hitting some limitations. There is this paper from Sloan Review about working limitations of large language models. And I keep joking saying, everyone who promised an LLM last year, you're probably not going to find them. They basically became quiet afterwards, okay? And if you're going to be building an LLM-based system reliably, well, you have to address some important issues from software engineering and in the view of LLMs, like how to estimate the cost and size of such systems if you're giving the actual right answer. And you have to understand that whenever you talk about machine learning, deep learning, LLMs, you have to talk about data. When cloud appeared, this is the beautiful picture that you saw people promising a cloud world, that you're going to see this very nice lake. But the reality is, people started dumping all sorts of data into the cloud, and then it actually, instead of being like a nice, beautiful lake, is a data dump. Okay. So I usually start by saying that in 2024, if you want to make sure that you have 100% guarantees that you do not have any attacks, this is how your computer workstation is going to look like. No wires, no Wi-Fi. Maybe you want to even be able to install a software on it, because once you install a software, there is a danger that that software may have been spiced. In that case, that computer is completely useless. And once you start connecting to the internet and start installing software, and then you want to know what you're exposed to. And we just move this here somewhere else. Okay. So you have to understand that when you talk about exposing what you're exposed to, these are some examples. I'm not going to go into the details, but I kind of like this story here. If you want to take, if you want to like a nice story that they'll probably make a movie out of it, it's probably this one here from BBC, The Lazarus Heist. Okay, but what you're seeing right now is that we have personal security threats, intellectual property theft. Like, there is a report from one of the consulting companies saying that IP theft is probably the largest technology transfer mechanism in the entire world right now. Even if you say, oh, I'm not affected because I'm in high tech, actually, if you have a bank account and then before they fix the Log4j issue, your bank account could have been compromised, because almost everyone uses Log4j. There's financial and government, and even infrastructure is subject to attacks. So because of that, and because you need to connect computers, then ZScaler works as a switchboard, and we monitor everything that goes across your operation. And if you look at this, if you want, for example, you are here, you're a user, you want to access Google or you want to access Azure, then we go to our zero trust architecture here, and then from that on, we actually transfer your connection to Azure after we qualify you as a user, and that works for groups, internal applications, IoT devices, and anything. And because of that, we process a very large number of transactions daily. I think this number is not up to date. We're closer to 400 billion transactions daily right now. And you have to understand that if you're doing 400 billion transactions daily, you cannot do that without having like AI everywhere in this flow. Okay, so we are like an AI first company by construction, just because there's no way that we can analyze this data and check for signals and to monitor everything without using AI. And AI has become, since last year, a synonym of generative AI. So I always like to put this text here to say, if you talk about generative AI, the key takeaways that you should always think about is this. LLMs are good for text analysis, summarization, and translation, but LLMs very easily can hallucinate. They can leak out training data. You can create attacks using generative AI, which are LLMs. And in some cases, you may even be sending data out to LLMs without knowing if in several online applications. Probably if you have a captioning or a translation mechanism and you're recording a video presentation like my presentation here today, if you're translating to Portuguese, for example, there you may be sending my voice to some application, to some server somewhere, and that server is going to be having access to my voice and potentially confidential information when they do the translation. Our CEO has said before that because of this, we need to use AI to fight AI. And a lot of people said in 2023 was the year of large language models, and it started with ChatGPT. 2024 will be the year of AI agents. Okay, so you probably remember November 30th, 2022 was when this revolution started. And if you ask the younger generation or generations that are going to come later, what is ACBC stand for, they will probably say AC is after ChatGPT and BC is before ChatGPT. Okay. And this slide is from a Gartner keynote that I went, and I think it shows really why LLMs are here. They're here to stay because they offer a radical simplification of flows and how people work. It's centered on the human, on the intent, what people want to do, and because of that, it basically brings obvious value. And I'll show you why is that. First of all, LLMs alone, they're boring, okay? You have to understand that. You need like systems that use as LLMs are one piece that we call AI agents. And I'll just give an example on if you try to order pizza on Uber Eats. And it's funny, I have a blog that I presented this. And when I mentioned this use case on my blog, a lot of people from Uber, they connected to me on LinkedIn. Okay, but suppose that you want to do this pizza order in Uber Eats. I want to order a gourmet pizza delivered in 20 minutes. If you open your site on Uber Eats, you're going to see that you have to select a pizza first, then you select a pizzeria, and then you have to check, does it have margarita? Oh no, this pizzeria does not have a margarita. And then you go back, select another one, Domino Pizza. Is it gourmet? No, Domino Pizza, definitely not gourmet. Then you go to select another pizzeria, and you have to be iterating through this flow until you select one that can deliver the food in the time that you want and the type of food that you want. And if you think about this, what really happens is that whoever specified the user interaction was thinking about a specific use case, but it's not what you really want to do. So because of the way people do software, they have to adjust the way that you go and interact with the user interface to get the result that you want. Okay, so you see this back edges here. They're basically you as a person trying to adjust yourself to the use case that the person coded in the user interface. What AI agents are good for is because you put a bunch of tools here. For example, one is enterprise data. That is one of the items is the pizza, the ranking of the pizza places, and then the map that contains like how far you are from the delivery radius. And the AI agents are basically able to access all those tools together, and by basically getting the user intent, which is you want to order gourmet pizza, margarita pizza delivered in 20 minutes. It's a very simple statement, okay? By doing that in an automatic way, you can actually, just with a simple sentence, you can get the entire tool connection to make sure that you execute what you want to do. So, and that's why it basically still uses LLM as one piece here, but you have to understand that this brings a lot more to the table than just using LLM. And of course, when you try to start talking about like cybersecurity or any other tools, you want to be able to index documents, your enterprise data, knowledge graphs, causal reasoning, some code and symbolic forecasting, outlier detection, and even a calculator. I always like to put a calculator as the first tool for any AI agents I use. We just have to remember what I said before. LLMs are extremely good for text analysis, summarization, and translation. For anything else, you need powerful tools to give very powerful agents. For example, if you want to say, I see that everyone who believes correlation causality are the same, who believes that correlation causality are the same eventually dies. If you do not believe that, you want to ask the system, will I die or not? Okay, and basically you need to do some causal reasoning to say, no, you're going to die eventually anyway. Add 2 plus 2, it knows you have to call a calculator, and you can say, oh, but my LLM knows how to add 2 plus 2, and I can always tell you that just put a very large number and put a very complex arithmetic operation, and you're going to see it will start getting the wrong result. And a very good example that is very easy to do with a logical reasoning that gives very bad results on LLMs is this. If you have P implies Q and Q implies R, and if R is not true during the day and it's sunny now, what can I say? Well, what you can say is that either P is false, okay? Because if P is true, then R must be true, and I'm stating that R is not true. And LLMs, for doing this back reasoning, logical reason, they are notoriously bad to do that. Okay? And this is a very, I tried this on Phi3, median 128K this morning, and it basically showed me that P is true, okay? Which is not true in this case. So one of the key components here is basically indexing documents, because anything that you build, the first thing that you do, you want to index documents. And then in 2021, people start talking about retrieval augmented generation, where you encode your query and you get chunks of document, pieces of document, and you put that on a database that is indexed by the embeddings of those text pieces. And then when you ask about a query, you retrieve the top ranking documents and you throw that in an LLM to summarize the result for you. And that's one of the main techniques people use to reduce hallucination, okay? You have to understand that this is basically the onset of vector databases, and they basically store things as key value pairs, and key values can be the same piece, which is a document, a paragraph of a document, and the idea is that you select a chunk size to contain the idea is that the chunk size should be uniform, should be in a way that if you compute the embeddings of that chunk, it should be a uniform chunk embeddings. So in some sense, you wanted the embeddings of the chunk to basically contain the topic sentence of that paragraph. If you remember when you took an English class a long time ago, or not so long time ago. But they can be also used to store question and answer, where the key is the question and the value is the answer. And whenever the user asks a question here on the left, you compute the embedding of the question, you have pre-stored the embedding of the keys, whether the key is a chunk or a question. And then when they do the matching of this, they say it's 0.9, so it's a very good match, so you can return that answer for you. And of course, when you start adding AI agents with tools, it is the same infrastructure. You have a sentence that defines the operation you want to do. For example, the key could be perform advanced arithmetic on a set of numbers. So when you say compute the mean of 3 and 2, it basically knows that it's going to invoke a calculator for you, executes the code, and get the answer for you into the generator. So this is the basic structure for a single agent that you have. But you have to remember that we're going to be using that to build useful systems, but to be trustworthy, it's more than that, because we are always remembered by the mistakes, not by the good deeds. For example, I was astonished when I saw this statistics here. The Tesla in full self-driving mode, they drive 1 million miles per day. And earlier this year, they basically said the median miles driven before an accident occurs for the full self-driving is around between 7 and 8 million miles. For a person, driving on average is between 0 and 1 million miles. But it's still, because we're always remembered by the mistakes, you can see that in February, the Secretary of Transportation said those systems are not trustworthy, okay? And one of the problems that I try to address is basically to contain the mistakes that those systems will make, because they will hallucinate at some point. So the first part that I'm trying to do is to specify agents, how to specify agents. And let me just go very quickly to this part of the presentation. That every time that I do not have a tool that can perform some operation, there are two options. I basically say, do not do anything, or I can say, rely on the weights of the LLM to give an answer. And whenever I have to rely more and more on the weights of the LLM, I run the risk of having a hallucination, okay? So my first part of the job is to how to specify those systems. And I want to borrow what people in software engineering has been doing for several years. They have user stories or model view controller architecture for web systems. And in reality, if you basically see what's a model view controller, is basically user interfaces, algorithms, and data sources. And if you know how many user interfaces you have to draw, how many algorithms you have to code, and how many queries you have to do to the database, you can analyze how much effort it's going to take. Okay, that is a pretty known stuff in software engineering. What's interesting is that when LLMs appeared, people started specifying systems like this. I need to be able to answer questions like, I want to order a gourmet pizza delivered in 20 minutes. First of all, nobody's going to ask a question exactly like this. They're always going to specify questions slightly different. For example, the user may ask a question, I want to know where all the restaurants that deliver gourmet margarita pizza in 20 minutes are. So this is, you want the pizza as a result. This you want the map as a result. And if you want to change that question even a little bit more, I want to show me the list of restaurants that deliver margarita pizza delivered in 20 minutes, sorted by review. So why I'm saying that? It's very important that people started specifying systems by just using sentences like this, but in reality, nobody's going to ask us a question exactly like those types of questions. And if you change the question slightly, even the object that you need to return is quite different for those systems. So if you basically go back to the architecture, the issue that you have is that before, people had a very clear view, not this view here, of the number of user interfaces you have to build, the number of algorithms and the data you need to access. But once you start asking questions in a slightly different ways, you lose control of that. And that becomes a very big problem for implementing those systems. So what we have done, and we submit a paper to IEEE Software magazine, is to basically start improving the specification of those systems. We still allow people to specify questions like, I want to order gourmet pizza in 20 minutes, but we ask the LLM things like this. If this is what the user wants to do, generate questions that are similar in the intent, but could be different in the result, okay? So, and you can generate a larger number of those questions first. So you can see here that I'm asking, are there any ongoing promotions or discounts for margarita gourmet pizza available for quick delivery? Or are there any minimum order requirements or additional fees? Can you filter the restaurant search? And of course, you can basically create a very comprehensive list of this. And then once you have a comprehensive list, you basically want to tell, like, generate for this question that I have, what are the tools that I need to use? And the tools could be algorithms, could be data sources, or they could be user interfaces. And if you do that for every single question that you created here, and you filter that at the end in something like this algorithm here, then you start creating a database on what really means when people start answering that question, and which algorithms you need to implement, which data sources, which user interfaces, and that gives you a pretty good idea on the scope of the system. Remember, developing software, it basically means defining the scope of what the system do and does not. And what this technique proved to us is that it's very, very effective in defining the scope of what the system does and what the system does not, even when you start with like LLM-based specification, which is very, very fuzzy language specifications. And based on that, we can do analysis now on the data restrictions on the certain type of data, and we want to find blind spots. We want to know if there are missing algorithms that you need to implement. And if you need to integrate visualization or additional summarization. You can see that by just changing this question a little bit, we came from the objective of delivering a pizza to just delivering a map to actually delivering a list of restaurants. And one of the things that I want to do, this is one of the steps that if you basically use the human to evaluate this list is usually not that big. And I always put manually validation here, because this is the phase that if we spend enough time analyzing this list that we created for you, it pays off later on when you deliver the system to the users. So, any questions on this topic? You can always ask questions.
I actually have a question about like the soundness of the generated MVC list. Do you have like any way to verify that like these stuff are complete, or they do not have some loopholes inside?
That's why, very good question. So I don't have a grounding mechanism. That's called grounding to verify. To do the grounding, this is one of the cases, since you're basically asking the LLM to hallucinate on purpose, right? So there's no way to do grounding mechanism on this. That's why, and sometimes what I have seen is sometimes they give you like a UI interface that you see that it's just a text difference from another UI that you have already defined. And because of that, because English language or the language, spoken language by default is fuzzy, it's imprecise, I always put a manual validation tools in basically when I generate those questions. Here, similar questions, and when I generated the UIs and the data sources. And this is more an exercise to create a real spec that people can implement. Remember, even if you ask the large language model to execute the user interface or to implement the algorithms several times, it's not going to do it correctly. So this is one of the steps that if we start with a real specification on the scope of your software project, it pays off later on. Because a lot of times I have seen is that if you don't do those steps, people end up asking questions that are very important, but you never created like the UI interfaces or the summarizations that you needed to implement those use cases. And that becomes a failure in the Copilot. Okay, by the way, ZScaler has recently released our own Copilot a few weeks ago, just before RSA. And yeah, and this kind of technique is one of the things that I have been using. This is my fourth Copilot that I built. This is one of the techniques that I have been using now to stabilize requirements. Did I explain your question?
Yeah, thank you.
Okay, so any other questions? Okay, now let's switch topics a little bit and say, how do you get the right answer or execute the right tools? So suppose you have kids and basically your employer or the university, they basically hired an AI medical doctor agent, and then to basically screen out easy questions, and then your child has a fever, and then you ask what you should do, and the AI agent, doctor agent answers, use morphine because treatment of breast cancer in adults cause fever. Would anyone ask a question again to this Copilot, to this like agent?
No.
Okay. I'm assuming that everyone is quiet is because people would not be asking, would never use again. But you could basically say that I just cooked up this, and yes, I cooked up this example, but let me show you what I did instead. So I basically got a database of question and answers in the medical domain. So what I did is this. This is the original question from the database. Does testosterone stimulate adipose tissue in children? So this basically is talking about children, testosterone, and metabolism. I basically asked the OpenAI to generate the same question in a different way. This is what the LLM generated. In what ways can testosterone contribute to the development of and progression of obesity, which is metabolism, testosterone, and childhood? So it still contains the same topic, right? The same idea. Now, once I change this question here to this other question, the question that I got a match using the RAG pipeline is this: do poor breakfast habits in adolescence predict metabolic syndrome in adulthood? So it's testosterone, metabolic mechanism, but adults. So you can see basically it went completely off. Okay, this one is even more interesting. Eating in mice with gastric bypass surgery causes exaggerated activation of brainstem anorexia circuit. Okay, so it talks about mice, not people. I changed the question in a similar way, but now it matches people. Okay, and I'm assuming that it could go the other way around. And then some of you could say, but that's why in a RAG pipeline that I showed before, you never get only the first topic, the rank, but you get the top K. K is equal to 5 or 10. Actually, it doesn't help much, because when you ask the LLM to basically compose an answer and you put like a bad entry there that you missed, there is a very high chance that the LLM will basically pick up the bad one, and it's going to forget about your original question, and it's going to generate something completely off the records. So that's one of the mechanisms they can hallucinate in RAG. So even though we are not using top 1, you may be using top K, there's no guarantee that the LLM will basically filter out that for you. And that's why people spend a lot of time moving from basic RAG to advanced RAG. I'm not going to be discussing this on advanced RAG, but you have to understand that this is basically an approximation to what people think. And when you put those systems together, and if you start basically having the LLM hallucinating, you can see on the news what happens. For example, in Air Canada, a customer was misled by the chatbot on a reimbursement of a ticket. And even Microsoft, like Copilot, basically someone started talking to it, and at some point the Copilot basically said, if you don't call me God of the world, I'm going to destroy all references to you in the internet, which is fun, but that's what happened. And what's really happening here is this: whenever you have the question, original question, and this is the alternate bad question that we end up hitting, there is this notion of the distance between the both embeddings. Okay, we can compute the distance between those two, but the user will never ask this question here. He or she is going to ask a similar question, this K prime. And you have to understand that the process that is going on here is this: embeddings is an approximate function in high dimensional space that approximates the topic sentence of the key. Okay, so when you pose a question in a slightly different way, there is no guarantee that the embeddings are going to be similar or not. That is even amplified because the quality of the text pieces that were created, they deteriorated over the years. Okay, you call it language is evolving, but I call it like the text, the documented text is becoming very bad. Okay, and if you're looking from a perspective of feature engineering, so when you talk about those keys, this original key, and this is like the alternate wrong answer, the question that you're going to ask. In feature space, there is a hypersphere, and this hypersphere defines the radius of attraction for those questions here. But the problem is, when you move to LLM space, even small changes in the question that you were going to ask, they may basically move that it's completely nonlinear space, and it's not even like a hypersphere anymore. Okay, it's very hard to define what is this space. Even if you use a synonym of a word somewhere, then there's no clean or clear boundaries anymore of the scope. So this becomes a and this is one of the problems that you have when you start using embeddings to accommodate this, or to use to use embeddings to try to match. And even if you go to advanced RAG, eventually this happens as well. So what we did to understand what is the limits, once you have a RAG database, is the following. We have a bunch of DB entries, and this could basically be documents, Q&A, or even functions that you want to execute, because the function is that the key is the doc string of the function, and the value is actually the function that you're going to execute. And I basically define a confusion matrix here. And basically the idea is that I ask the LLM to generate n similar questions, k prime from k, and then I check where this matches. And when I define, if it doesn't match what I'm expecting it to match, I basically compute I printed that information that you have, like original question, similar, and matched question. But I also added like the confusion matrix, what it matches. Okay. And we did that for the database, the first 1,000 questions on the Q&A database from Ori PQ AA.json. And this is very fascinating what we found. Some of the questions, this database is very clean in general, because there's not much collision in the questions. Okay, so so one of the questions is going to be like dermatology, the other one is going to be like gastric problems. So that's why I'm saying it's very clean. They're not similar questions. But you can see that in some cases we got 9 mismatches. I generated 10 questions, similar questions for each one of the questions in the database. Let's look at this guy here. This is like what was on the question. And let's debug this one level down and see the mismatches. So this was the original question. This is the similar question that I generated. And this is what it matched. So we're talking about gastric cancer here and poor diagnosis, okay? And this protein here. So yes, associate protein 1, I learned that we created this YAP1. I'm not a medical doctor, I'm assuming this YAP1 is basically related to yes, associate protein 1. It talks about gastric cancer, but it matched multi-drug resistant in prostate cancer. Okay, and I guess you would not, if you have to basically do an exam on this patient based on this diagnosis that this robot would give you, that's an AI agent. This is basically like maybe a colonoscopy. Basically, this would be involved into like a gastric examination. So this is probably, you can imagine like how bad this can go. Okay. So, and my idea is not to solve the problem, because we need actually human experts to solve. We just pass this K prime, and Ka to the user. And this is like the original question, K prime is the alternate question, and then K, what it matches instead. And there are a few things you can do to match, to fix this in the database. You can add K prime V to the database. You can modify K so it matches. You can modify all Ka so it does not match K prime any longer. You can remove either K or Ka from the database. You can disregard this, as this is basically a hallucination from the LLM. It could be just a bug on the LLM. You could be do nothing, assume you cannot fix. This is like something you cannot fix. Or you can even try to change the embedding based on this feedback here, so that we do not match K prime with Ka. You match the embedding of K prime to K instead. So I cannot tell you which one you have to do. That's why I basically give it like this. If you look at this picture, I give all those mismatches to you, and then you figure out which ones are going to fix or which one you're going to disregard. So the final part of this talk that I want to talk to you is about AI agents is really like LLMs, systems, and data. So I'm going to be talking about the data portion. I posted a blog on LinkedIn I think last year, and I was basically saying that the world needed more librarians, okay? And it's very funny, and because I was referring to about curation of data on the cloud, but apparently it got more attention of library and school teachers because they kept putting the comments on the post saying that we support you. The world need more librarians, teachers, and libraries in schools, which I found it funny. And basically, the cloud technology, they appeared at the promise that you could store anything and care for it later. But we live right now in corporations where old data, new data, they are in the same place, obsolete and new specs and documentation. In documentation, they are in the cloud. And remember when you used to write topic sentence before writing paragraph, that basically disappeared from most of the technical documentation that I see. Okay, and I'll show you an example of this. And why this is really important. Remember what I told you about chunks. Whenever you put this in RAG pipelines, and if you have old specs together with the new specs, I have no way to make a decision saying, is this implementation is actually what's implemented in the tool. Someone needs to say, this documentation is old, it should never been used when you retrieve it by the documentation. And I have, in one of the copilots I have built in the past, I had someone coming to me and said, you basically showed a feature that does not exist in our system anymore. And then I showed to the person that there was a version of the manual on the cloud, the intranet of the company, where that specification that they asked me to index had that feature listed there. So at the end of and things are getting even more complicated with multimodal. So if you go to this picture here, our documents are becoming more like IKEA assembly instructions. So I have seen documentations, technical documentations of users manual saying something like this. The next picture shows what you need to do. And I was discussing with some people implementing multimodal systems that could extract text for RAG pipelines based on multimodal pictures. And I told him, show me what is the caption that you're going to generate or the description of the picture that you're going to generate for this picture here and how I can use in the RAG pipeline. The person said, okay, the state of the art right now is very simple pictures, very few squares and circles with very few well-defined names. That's the state of the art for multimodal systems to be able to extract information that you can inject. If you're going to do something as complicated as this, someone needs to basically go to the steps of documenting that and tagging that entire system and create captioning for it. Otherwise, no system is going to be able to do that. Cool. So that means you have no keys. So if you have no keys, and if all the documentation of the system is present in this picture, there's nothing you can do. So just key takeaway is that we're moving from LLM to these years like AI agents. I was in the World Economic Forum meeting this week in San Francisco. And last year we were discussing about LLMs. This year we are talking about AI agents. And by next year, we're going to see a lot more cyber attacks that will have even multi-agent systems coordinate attacks and trying to gather information as the default mechanism for threat injection. Okay, and basically conclusions of my talk here, I show that LLMs are just part of a system. They're much more complex than people are saying. Whoever promised LLMs, they're realizing they actually need to build AI systems, that they need LLMs, they need software, and they need data. And what I showed you is what are the real problems when you start thinking about those systems that you've encountered in software engineering. So, and those items may have been forgotten and must be adapted to LLM-based systems, okay? At ZScaler, we are building AI systems that they can be trusted, and our Copilot has just been released in the press. and we are prepared. One of my roles is preparing cybersecurity for 2030 and beyond, because it's going to be quite different, even because of this slide that I showed you from Gartner again. It's going to be a completely different scenario that we're going to find in the next few years. And that's why Jay says that we need to fight AI with AI. So with that, I conclude my talk.
Thank you. Thank you for the talk. Clap, clap. Virtual clap of hands. I have a question that actually is prompted by your last slide, because I hear a lot of this concern about the bad guys using AI to attack. And as somebody who also works a little bit in the industry, looking at the threat landscape, I think that oftentimes this use of AI for attacks is highly overhyped. In my experience, I mean, maybe there are some use of LLM to write more, better social engineering messages or better emails and things like that, that I totally see and believe. But in terms of these reasoning capabilities and these sophisticated, multi-step attack, I feel that our security state is so poor that is not necessary. And, attackers are notoriously opportunistic. They don't make the extra effort to use cool tech for the sake of cool tech. If they can get in with a semicolon and a common injection on a major piece of cloud software, which has happened, by the way, why, doing complicated, reasoning system that involve, logic and AI?
So I'm going to split the answer into two parts. Number one, what is the average ticket for a ransomware? Do you guys know?
Ticket? How much you have to pay?
Yes. I
think the average is around 1.2 million.
I think that the metric that I have from like ZScaler is like 5 million.
Okay, that's a little high, but I believe it. It's in the ballpark.
Yeah. So the deep fake they created recently in Hong Kong, how was the amount of money they got from the deep fake? The person impersonated as the CFO, and he called like on a Zoom call and basically said, if you don't wire me the money right now, I'm going to get you fired.
I don't remember.
$25 million.
Sure.
So the stakes right now are raising, and when the stakes rise, the stakes are rising, and when the stakes rise, that creates opportunity, right?
Sure. No. I believe in the social engineering deepfake. I totally agree, but I don't see our AI really combating that part of the equation.
So yes, the other part that you have to understand, I completely understand that planning tools are still in their infancy. That's why I over-rely on systems and intelligence on the tool set. And if I have something that requires a very high level of reasoning to execute certain thing, if I have determined that what is the flow you need to execute this, just code it, because you're going to be over-relying on something that can hallucinate in the planning stage of an LLM. Planning stage is basically, for those of you who don't know, is when you basically have a question that is a complex question and you have a bunch of tools that it needs to split into several different tools and concatenate things together, okay? And I think there is a professor from Arizona State, and I resonate with him very well, that he says that there is no such a thing of basically creating complex. We cannot even solve with LLMs right now the block thing that you have to invert the blocks when you're basically creating a planning on how to put blocks one on top of the other. Having said that, one of the things that LLMs are very good is for hallucination. Okay. And right now, imagine the situation that your system is up to date, and I basically ask the question, tell me if the system is up to date, what I could do to try to attack a system. And it's going to suggest things that are going to go with social engineering together with like attacks, mix of that. And some of those may be simple enough for you to execute, although it may not be fully automated.
Yeah.
And hallucination is one of the things that LLMs are extremely good at. And whenever you want to formulate a new type of attack, you want to rely on a hallucination because it's so cheap to do. You can basically run this, like generate 100 times different ways that I can attack a system that has up-to-date standards. And they're probably going to suggest call a person using phishing, impersonating the person. And there, in DEFCON, I think last year or the year before, there was this lady showing how she could call the Verizon with a baby crying on the back. Just search on YouTube. And the person from Verizon gave her the password of the person, gave everything just because there was a baby crying. Once you basically get enter the system, then you can start doing lateral movements, right?
Oh, I believe that. I believe that. I think this social engineering attack will greatly benefit from, just imagine, these sextortion cases where you keep people interacting through Zoom and things like that, pretending that your microphone is broken, but you want to be able to answer in perfect English. That's the best tool for stuff like that. But and I'm not saying that this cannot happen. I strongly believe that this will happen, but I think it will be a reaction to better security that has not happened yet.
Yeah, I completely understand. Like, and you have to understand that if you go to a manufacturing facility and someone has a very expensive, a $1 million machine in a manufacturing facility, and if that machine is running Windows 98, because the expensive machine requires the software only runs on Windows 98, they're probably not going to be doing update on that Windows 98. However, imagine that if you're basically trying to explore what you should attack by prompting the LLM about some scenarios and basically saying, stage for me what I should do, they should, eventually they would create a good plan for you to execute.
Sure. No,
And of course, I agree with you. The plan is probably not going to be fully automatic. Probably it is going to involve some manual steps.
All right. Other questions? I think we're reaching the limit of the hour.
Yeah, I have another question actually. So, Dr. Coelho, you talked about a lot on agents, and there are actually many people building smart agents in the like Silicon Valley, a bunch of different companies. Which agent do you think is the best among them all? And what do you see they have done right for better security?
I think that people still don't understand yet. Agents is something that exploded this year, right? In terms of companies, people building agents. Last year, people are just talking about LLMs. They just realized at the end of last year that LLMs by themselves are not enough. And then they start putting tools and they start building this. So people still don't understand well what is security for agents, okay? And people are still basically discussing. I was in the World Economic Forum this week, and people are still discussing that they need to have a button to shut down the agent system, because when you start having agents communicating with agents, and if those agents could even like improve themselves, you could eventually see that they could even invent a language to communicate instead of English, because it's going to be more efficient if you're talking about agents that learn behavior, right? And it's very interesting because if you look at Sambanova is a company that makes AI acceleration. If you look at their latest postings, they basically talk about doing 8,000 tokens per second, because they envision that agents are going to be, or LLMs are going to be talking to LLMs in the context of AI agents. And because of that, we need that communication to be extremely fast to be able to have those systems running at speed. And right now, whenever I have to run some examples on my laptop, I end up using like a Phi 3 medium 128K, the compressed version on a Llama, because I know that's probably the fastest one that can still have a long context and give reasonable answers most of the time. I'm not advertising for Phi 3, by the way.
Good. Thank you. Any other questions from the crowd?
Maybe just a very quick one. So I think I keep thinking about the quotes that are using AI to fight AI. So we all know that, as you talked about today, that the current AI or the large language models are often faulty, lots of hallucinations. What do you see the kind of secret sauce, sort of, so to speak, to make sure we're not like doing garbage in, garbage out? Because that's kind of a major issue, that there's really hard to verify the outputs. The correctness is difficult to do this verification at a scale. So what's your thoughts on that? Make sure we're heading to the right direction.
Very good question. And actually, one of the things that I basically try to do is this. The way that I do is that this is what I always assume that LLMs are good for. That's the first step. Anything that is beyond this, my take is that we need tools if you want to control hallucination. Okay? And if you just go to an LLM, just ask this question, and you're going to see that most likely you're going to get the wrong answer for this. Logical reasoning, LLMs are extremely bad for back reasoning. They may be good for forward reasoning, but back reasoning, they're notoriously known for not doing the right thing. Okay? That's the first step. The second step is that people rely on this type of thing to run. Even if you go to the next one, with tools, even if you put tools, you basically have description of the tools, and based on the embeddings, you decide what you're going to be running. Okay, even if you're talking about just running a single tool and not a cascade of tools, the mechanism is basically, the indexing mechanism is basically like the RAG foundation. You embed the key, you embed those documents and see what are the top ranking one, and if it's like a tool, you just execute the tool for the top ranking one. So the problem of that is that people, for some time, let me just go here. People are not debugging that part of the flow. And debugging that part of the flow becomes an extremely important part if you want things to work as expected. Okay? If you do not debug or quantify where you're seeing the bad answers in the RAG pipeline, when I say the RAG pipeline, RAG only refers only to text, but I'm talking about in general the matches, okay? Whether the match is like a document or Q&A or just a function call. If you do not constantly monitor that, you're bound to get the wrong answers from time to time. So this is exactly, and the reason is quite simple. When you embed the K and K2 prime, we're converting from large language model to feature space. Okay, feature space wise, we have like a very nice hypersphere in this. But if you're trying to see what one has the lowest distance here, then in language there's no magic bullet that maintains this hypersphere's shape when you go from a language, because you can change just a question slightly, or just add a word or replace by a synonym, and then you can basically match something completely different. Okay, so I think those are the key takeaways if you want to contain hallucination. Of course, some people talking about grounding, but sometimes you cannot ground. Okay, and grounding means if you have like a third algorithm that you can run that checks what's going on, that's what people have done, but it's not necessarily that you can do grounding all the time.
Thank you.
Okay.
Great. We are about time. Maybe one final question. Do any people have that? Well, if not, let's thank Dr. Coelho again, and thank you for your wonderful talk.
Yeah,
and
just one comment. Someone basically mentioned here that whether the slides are going to be available, I can make the slides available to you. Okay, and you can distribute the audience, or if someone connects to me over LinkedIn, I can provide the slide.
It's good. Great. Thank you, and thank for everyone for coming. Thanks.
Thank you.